In this example, we're solving a projectile motion question of a ball that's kicked off of the ground. So let's imagine here's the ground. I can draw a straight line. Here's the ball. The ball is kicked. The ball is kicked in that direction. Let's say 20 degrees above horizontal. So here's horizontal, and we're kind of going up from horizontal. So 20 degrees above horizontal. It's kicked at 25 meters per second, so V1, 25 meters per second, 20 degrees above horizontal. It's not going to go in a straight line. Because of gravity, it's going to, I don't know, do something like this. It's going to bend and come back down to the ground and land over here. What we're asked to find out is the horizontal range of the ball, as well as maximum height and horizontal range when it's 2 meters off the ground. Let's just worry about A for now. The horizontal range, what that means is, what is this distance? So from here to here, we call that dx. I'm going to write it down here a little bit. Dx, that is horizontal range. That's what we're looking for in part A. So this is dx, this horizontal range. If it's kicked in that direction, even though it's not going to go in a straight line, if it's kicked in that direction, we can imagine a triangle. Okay, so its initial velocity is going this way. This is going to be V1 in the x direction. If this is V1 in the x direction, V1 in the y direction. So how fast is it going forwards, and how fast is it going up as it leaves the ground? These numbers, well, this number will remain constant. This number will not remain constant. Okay, so a couple of things in this. Let's kind of move into part A here. For solving this thing, we're going to break this thing into what's happening in the horizontal direction, what's happening in the vertical direction. Well, okay, let's go here. Vertical. We'll often just say like the x direction and the y direction. That's typically what I would write, not horizontal and vertical, but anyways, same thing, horizontal, vertical. In the x direction, V1x, if we just look at a little trig ratio in here, this is a nice right angle triangle. It will always be a right angle triangle because x components and y components are at 90 degrees. This x component, if you think of this 20 degrees, cosine of 20 degrees is adjacent over hypotenuse. If I rearrange that, here, let me squeeze this up here. Cosine of 20 degrees is adjacent, which is V1x over hypotenuse, and the hypotenuse is 25. If that 25 can come up here, typically I would just write, I would write 25 cos 20 degrees. And just kind of jump right into that. If you need to kind of write this step to sort of see what's going on, that's great. But I'll typically just go right to this. This number is, you can leave it like this. Some people like to leave it like that. Or some people would rather see kind of what is this number. It is this, meters per second, and I'm going to squeeze a little forwards in there. This thing is going only forwards. If we look at this ball, the ball is kicked on this angle. It's going to travel this way. It is going this fast in the forwards direction as it leaves Marwan's foot. In the vertical direction then, I'm going to get 25 sine 20 degrees. And you can imagine doing the same thing, right? Sine 20 degrees equals opposite V1y over hypotenuse, which is 25. We can rearrange that and we can get this line. V1y, this is a y for vertical. V1y, and that ends up being 8.55 meters per second. That's going up, okay? And another tip off to that is it's above horizontal. If it's above horizontal, it's got to be going in the upwards direction. It's not going to continually move upright. It's going to go on its way up. It's going to reach a max height, then it's going to start coming down, but this is the initial. A couple things we know as well, AX always is 0. There is no acceleration. Once this football has left Marwan's foot, it is not speeding up in the forwards direction or slowing down. But in the y direction it is. There's a acceleration of 9.8 meters per second squared. That's just gravity, right? Down. That's always going to be true. These two things are always true. AX always 0, AY always 9.8 down. What else do we know? We don't know, let's see, for the horizontal range, we don't know the time it takes. The time would be the same here and here. Both are unknown. We don't know that time. Okay, so let's do this then. What I want to find is dx. Okay, so that's what I'm looking for. I might need to know other information, maybe V2 or time or something like that. The equation that I would like to use is this guy. I call it the best friend equation. AX is 0. This thing is going to be 0. What I'm left with is distance. This is dx, this thing that I'm looking for. I know v1x. I don't know time. So time is a question mark. I'm stuck. I can't sub into this equation. So you kind of hopefully remember this from grade 11. We're going to come over here to the vertical direction, hopefully try to solve for time. If I can solve for time, then I can put it over here and finish off my horizontal. What that means though is I need 3 things over here. I know v1y, I know ay. The last thing I know, if the ball's going to land back on the ground, is the displacement in the y direction. This thing starts on the ground, so here on the ground, but it's at this height. It goes up and it comes back down and ends on the ground. The displacement in the y direction is just 0. It starts at ground height on this line, it ends at ground height on this line, its displacement is 0. I'm going to use the same equation. Displacement, 0. All of this stuff is in the y direction. Okay, so sometimes people will do this. They'll go through and put their y's in, or you can just remember it's all in the y direction. I can't use any of these numbers, only these numbers. dy is 0. v1y is this 8.55. 1/2 acceleration, negative 9.8 times squared. I should just quickly do this. Up is positive, forwards is positive. That's what typically people like to do. If you like to say down is positive, that's fine. That'll be positive, but this number will be negative. We should get the same answer. If I simplify this a little, 8.55t minus 4.9t squared, bring 4.9t squared to the other side. We can actually cancel a t out. Just remember as you do that, this is one answer to this. This thing really is a quadratic equation. There's no c, but there's the a value and the b value. There's no c value. Okay, so that is one of the 2 answers. I can also divide both sides by t, then divide both sides by 4.9. Really, I'm canceling a t. Then I can divide both sides by 4.9 and solve for t. T is 1.745. Okay, so what are these things? This is how long does it take to the end? This is how long does it take to the start? This is at the beginning, let's say. This is not the answer I'm looking for. This is the answer I'm looking for. Once I know that, that is also this time right here. Okay, so this is also 1.745 seconds. The time is the same always, so this guy and this guy are always going to be the same. Okay, always the same. That's true always in projectile motion questions. Now I know this thing. So v in the x direction, v1x is 23.492. Time, 1.745. dx then is, it's approximately 41 meters. Okay, that is the horizontal range. Hopefully you can see all that. I'm a little off the page here. There it is. So I went through in the y direction, found the time. Sorry if you couldn't see that earlier. Then I use the time over here, go through and solve for dx. Let's make kind of a double line here, and we'll see if we can squeeze in b and c on the same page. To find the maximum height, I'm going from here to here, which means I don't have all of the same things, I guess, the same numbers. For example, this time being 1.745, that's the time all the way to the ground. I instead want to go from here to here. You could say, wouldn't the time be exactly half of that? Yep, you're correct, you can use it. We don't have to though. We could say, looking in the y direction stuff over here, we could kind of say we have all of that stuff. We also know that V2y is 0. Okay, so V1y still 8.55. Acceleration y still 9.8. Down. Let's do this at the side over here. What I'm looking for is maximum height. I'm looking for dy. Okay, so this is from here to here only. Hopefully I can get that in there. Let's see, we can use v2 squared, v1 squared, 2ad. v2, this is all in the y direction. Again, you can put those in, you don't have to. Tell me that you're in the y direction somewhere. v2y, 0. 0 squared is just 0. This one, 8.55. This guy, negative 9.8. Again, we set up as positive over here. dy, that's what we're looking for. We're going to rearrange. I'm just going to do some quicker math here. We'll rearrange and we're going to get approximately 3.73. dy is about 3.7 meters. And that would be our max height. And finally C, we'll see if we can squeeze this one in here. For part C, we're looking for the horizontal range. Right, not the same horizontal range. We're looking for the horizontal range when the ball is 2 meters above the ground. Just remember, max height is 3.7. So all the way up to here is 3.7. That means 2 meters is somewhere maybe around there. This is going to happen twice, once on the way up and once on the way down. It's going to be 2 meters off the ground at 2 different times. Okay, so what we're going to do then is we're going to stick in the y direction. So v1y still 8.55. Acceleration still 9.8. Down. That's an equals. We no longer know our displacement. Well, actually, we do know our displacement. It's no longer this. It's not the max height anymore. It's when is it here 2 meters above the ground. Okay, so here on the way up, it starts on the ground, and our stopping point for the question is when it's 2 meters above the ground. dy then is 2 meters up. You could say, what about when it's here? Absolutely, it's still 2 meters up from the starting point. Okay, so still 2 meters above. What I'm going to look for then is the time. I want to know where is it, so horizontally where is it, but to do that I'm going to look in the vertical direction. Okay, so this is the y direction. I'm going to look in the vertical direction and I'm going to solve for when is it 2 meters above the ground. Then I can use that in the horizontal direction to solve for this horizontal range. So here's what I'm going to do. I'm going to use the best friend equation again. I call it the best friend because I seem to use it a lot. Distance or displacement, actually 2 meters above the ground. v1y 8.55. t, I don't know. Acceleration negative 9.8 t squared. 2 equals 8.55 t minus 4.9 t squared. We're going to bring 4.9 over to the left hand side, so it becomes positive. We're going to bring that guy over, it's going to become negative. This guy is already on that side, it remains positive. I've moved everything off this side, I get 0. This is a quadratic. I'm almost out of room here, so I'm going to say use the quadratic equation. And hopefully you remember how to do that. You can do it on your calculator if you have a decent calculator. The quadratic equation is going to spit out 2 numbers to me. It's going to spit out this number, or it's going to spit out, let's squeeze it over here, 1.47 seconds. Now, often when we use the quadratic equation, we're used to getting like one positive answer, one negative answer, and we throw away the negative answer. What we're seeing here then is 2 different times, because remember, we said this happens here on the way up and over here when it's on the way down. The smaller time must be the first time, the bigger time must be the later time. So this one's on the way up, this one's on the way down. I'm going to use this with my horizontal information. Okay, so just as a reminder there, v1x is still this. Remember, this thing does not speed up or slow down in the x direction. It's a forwards. AX is 0. I don't really need to write that, but I'll write it just to remind you. What we've got now is we've got time, let's call it time 1, and we've got time 2. So we're going to use both of those. What we're looking for is what is dx, and you could call it dx1 and dx2 if you want. We're going to look for two different ones. Okay, so in our x direction, really, because acceleration is 0, if you remember back to this equation over here, the acceleration portion cancels out, and what I'm left with is just this part. We're looking for dx. V is this, 23.492 time 0.278. This is dx1. This is approximately 6.53 meters. We're going to do the same thing using the other time, dx2. dx2 then is same vx, 23.492. The time here though is 1.47 seconds. dx2 is 34.53 meters. Okay, so we're looking for the horizontal range when it's 2 meters above the ground. You could say dx1 for sig digs, 2 sig digs, I guess, 6.5 meters. Or dx2, 35 meters. It is 2 meters off the ground once on the way up, and a second time on the way down. And that's it. That's a long question, but that's it.